Okay, we're going to look at some sketching completed squares questions. So taking a question, completing the square and then making a sketch, or taking a question where we've already got a completed square and making a sketch. So there's three features that we need to note with these questions. First of which is, will the parabola be concave down or concave up? The next thing we need is the turning point. And finally, we need the point at which we cross the y-axis. Okay, so let's try a couple of questions. First of all, let's complete the square with y equals 2x squared plus 12x minus 3. So quite often that will be written as, write it in the form something like that: a bracket x plus b all squared plus c, and identifying a, b and c. Okay, so let's first of all complete the square. So take out a numerical common factor of 2, bracket x squared plus 6x, close the bracket, minus 3, half the 6 down to a 3 and create a squared bracket. 3 squared is 9, times that by 2 is 18, get rid of that, and I still need to take away 3. And that will be 2 bracket x plus 3 all squared minus 21. Well, first thing that I can say immediately with the question is we can see that it's a positive x squared, therefore it's concave down, U-shaped parabola. I can then get the turning point by changing the sign of that to get minus 3 and not changing the sign of that to keep it as minus 21. That will give me the turning point. And then check the point at which intercept the y-axis. Now what's true in the y-axis is that x is equal to 0. So going back up to the function, replacing x with 0, 2 bracket 0 squared plus 12 lots of 0 minus 3, and that will collapse down to minus 3. Now I could get the same result by subbing x equals 0 into the completed square. So just to show you that will give you the same result. 2 bracket 0 plus 3 all squared minus 21. Well, 0 plus 3 is 3. 3 squared is 9. 9 times 2 is 18, and 18 take away 21 will give me minus 3. So I've got the shape of the curve, which is concave down. I've got its turning point, and I know that I cut the y-axis at minus 3, so let's execute that now on a diagram. So minus 3 minus 21 might be about there. I cut the y-axis at minus 3. It should have a nice U-shaped kind of continuous look about it, and that's reasonable. Okay, we're going to complete the square and make a sketch for 4x squared minus 12x plus 5. Okay, take out the numerical common factor of 4 bracket x squared minus 3x, close the bracket, plus 5. Half the minus 3 down to minus 3 over 2, create a squared bracket with a 4 at the front. Square of negative will be positive, so I'll need to get rid of that. 3 squared is 9, 2 squared is 4, that's 9 quarters. 9 quarters times 4 is 36 quarters. But think about it, 36 quarters is 9, so that's minus 9 plus 5. And that will be 4 bracket x minus 3 over 2 all squared minus 4. Now, I need to establish, is it concave up or concave down? I need to establish the turn point and the point at which I cross the y-axis. Well, first of all, it's a positive x squared, so it's definitely concave down. To get the turning point, I'll change the sign of that to get the x coordinate of the turn point, which is 3 over 2, but not change the sign of that, which will give me minus 4. So the turn point then is 3 over 2 minus 4. The point at which I cross the y-axis, I know that x is equal to 0. So going back up to the function and replacing x with 0, 4 lots of 0 squared minus 12 lots of 0 plus 5 will collapse down to 5. Again, let's have a look and prove that it will get the same result by subbing x equals 0 into here. Okay, so that will be 4 lots of 0 minus 3 over 2 all squared minus 4. Minus 3 over 2 all squared is 9 quarters. 9 quarters times 4 is 36 quarters. That's 9. Take away 4, and again that does give me 5. Let's put it all into a diagram. So 3 over 2 minus 4. That may be around there. And hit the y-axis at 5, and it's concave down, making sure that it's continuous and U-shaped. There's the final answer. Okay, let's look at a few examples where you've already been given the completed square and you just need to make the sketch. Okay, so I can anticipate that if I expanded that out, I would get a positive x squared, which means it's definitely concave down. Change the sign of that. Do not change the sign of that. Will give me the turning point, which is 2, 5. I'm now going to check the y-axis by making x equal to 0. So I'll go up to the function and replace x with 0. Minus 2 squared is 4. 4 threes are 12. 12 plus 5 is 17. And I've got enough information now, so the turning point of 2, 5 might be around there. It's concave down, cutting the y-axis at 17. And there we go. Okay, next one. Minus 3 bracket x plus 1 all squared minus 7. Okay, so if I expand that out, I'll get a negative x squared, which is concave up this time. Change the sign of that to get the turning point x coordinate, and don't change the sign of that. That will give me minus 1, minus 7. I'm then going to check the y-axis and make x equal to 0. Minus 3 bracket 0 plus 1 all squared minus 7. Okay, so 0 plus 1 is 1, 1 squared is 1, multiply that by minus 3 is minus 3, minus 3 minus 7 is minus 10. Let's put that into the diagram. So minus 1 minus 7 might be around here. Cut the y-axis at minus 10, and it's concave up, and a nice kind of U-shape to that. Final answer. Let's try another. So 3 bracket x plus 2 over 3 all squared minus 5. Okay, so if I expand that out, that's going to be a positive x squared. That's concave down. Turning point, change the sign of that to give me minus 2/3. Do not change the sign of that to give me still minus 5. That's my turning point. Check the y-axis, make x equal to 0. And that's 3 bracket 0 plus 2 over 3 all squared minus 5. 0 plus 2 over 3 is 2 over 3. 2 over 3 squared is 4 ninths. 4 ninths multiplied by 3 is 12 ninths. So I've got 12 ninths minus 5. And that's 12 ninths. Take away 5. I'm going to change that into ninths. That'll be 45 ninths. 12 ninths take away 45 ninths is minus 33 ninths. But I can divide top and bottom by 3. That'll be a minus 11 thirds. Okay, so it's concave down, there's my turn point, and there's the y-intercept. So minus 2/3 minus 5 might be around there. Minus 11 thirds, so that's just shy of minus 4, that might be around about there. And it's concave down, and it's important to annotate the diagram as well, which is to put the information into the diagram. Okay, let's try another. Let's sketch the completed square of minus 5 bracket x minus 2 all squared minus 7. Okay, so if I was to expand that out, that would be a negative x squared. That's concave up. Turning point would be 2 minus 7. And I'll check the y-axis by making x equal to 0. So that would be minus 5 bracket 0 minus 2 all squared minus 7. 0 minus 2 is minus 2, minus 2 squared is 4, 4 times minus 5 is minus 20, minus 20 minus 7 is minus 27. 2 minus 7 might be around there. I'm cutting at minus 27 on the y-axis and it's concave up. And there is the final answer. Okay, let's try one more. We're going to sketch completed square for minus 3 bracket x minus 4/5 all squared plus 5. So again, if I was to expand that out, that will be negative x squared concave up. Turning point, change the sign of that. 4/5, do not change the sign of that. 5, turn point is 4/5 5. And then check the y-axis by making x equal to 0. Minus 3 bracket 0 minus 4/5 all squared plus 5. 0 minus 4/5 is minus 4/5, square that and I get 16/25. 16/25 multiplied by minus 3 is minus 48/5, and then I'm going to add on 5 but change that into fifths, and that will be 25/5, which is minus 23/5. I can then execute that in the diagram. So 4/5 5, 4/5 is just less than 1, so that could be reasonable there. That's my turning point. Minus 23/5, that's just less than minus 4, between minus 4 and minus 5, so that could be about there. And it's concave up. The final answer.